Chapter 12, Probability and Statistics. Okay, so we're going to start with 12.1, which is the fundamental counting principle. And it's actually going to have some permutations in here as well. So we're going to get started with this. So the fundamental counting principle of two events. Basically, what we're saying here is if you have one event that occurs m ways and another event that occurs n ways, you are basically going to take m times m. That's all you're going to do. You just multiply them. Okay, all you're going to do is multiply the events together. It's literally all you're going to do. If you have an event that occurs 2 ways and another event that occurs 5 ways, 2 times 5 is 10 ways. That's literally all you got to do here. All you got to do is multiplying. That is the fundamental counting principle dealing with 2 events. Well, guess what? It can deal with 3, it could deal with 4, it could deal with 18 events, and it's still the same. What we're saying here is if you have one event and occurs m ways, another one that occurs n, and another one that occurs p, basically all you're going to do is multiply them all together, m times n times p. So if one event occurs 2 ways, and another one occurs 5, and another one occurs 7, all you're going to do is take 2 times 5 times 7, and it will occur 70 ways. So in example 1, the police use photographs of various facial features to help witnesses identify suspects. One basic identification kit contains 195 hairlines, 99 eyes and eyebrows, 89 noses, 105 mouths, 74 chins and cheeks. The developer of the identification kit claims that it can produce billions of different faces. So we want to know, is this claim true? Well, basically what we're saying is you have 195 different hairlines. We're going to use the fundamental counting principle. That's basically how you solve this problem. If you have 195 different hairlines and 99 different eyes and eyebrows and 89 different noses and 105 mouths and 74 chins and cheeks, basically what we're saying is I can choose any of those 195. I could choose any of those 99. I could choose any of those 89. I could choose any of those 105 and any of those 74. And each one's a different combination. I could have many, many different combinations of them happening. So that's why we're just multiplying all those numbers together, which basically gives us 13,349,986,650. Okay, no problem. So is the claim true? I'm sitting there, I'm telling you, I go into your police office and I say, I can create over 1,000,000,000 combinations. Well, the guy's actually being truthful. I walk into your police office and I'm telling you the truth. I could actually be a little more specific. I could even say to you, hey, I can do over 13 billion combinations of faces with my software, my identification kit. So if I wanted to, I really could, and I could prove it to them. So the claim is true, is the point I'm getting at. But now a witness can clearly remember the hairline and the eyes and the eyebrows of a suspect. How many different faces can be produced within this information? If the person knows what the guy's hair looks like, he doesn't have 195 choices for the hairline anymore. He doesn't. Let's be honest. If he knows what the person's hair looks like, he only has one choice for their hair. And if he knows what the guy's eyes and eyebrows look like, he knows what they look like. He doesn't have 99 choices anymore. He only has one choice, which means he has one choice for the hair and one choice for the eyes. But he still has no clue what the nose looks like, which is why he has 89. He still has no clue what the mouth looks like, which is why he has 105. And he has no clue what the guy's chins or cheeks look like. So it's 1 times 1 times 89 times 105 times 74, which is 691,530. So keep in mind, just by knowing the person's hair and eyes, cut down the different types of combinations it can be drastically. So example 2, the standard configuration for a New York license plate is 3 digits followed by 3 letters. Okay, that makes sense. But before we do this problem, we need to figure out how many digits there are, and we need to figure out how many letters there are. Now, this digits one, for some reason, confuses who knows what out of kids, and I have no idea why. I ask you this question: how many digits are there actually? Okay, how many digits are there? For some reason, I get this response all the time. Oh, there's hundreds and thousands and millions of digits. Well, No, there's not. Okay? There's hundreds and thousands and millions of numbers, but there's not that many digits. How many digits are there actually? There's the digit 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's only 10 digits. The reason why there's only 10 digits is because, for example, the number 19, I take the digit 1 and the digit 9, I combine them together and make 19. So there still is only 10 digits to choose from, and those digits are from 0 to 9. There are also 26 letters as well. So the point I'm getting at is in the letters of the alphabet, you have A through Z. So now that we know how many digits and letters there are, how many different license plates are possible if digits and letters can be repeated? So it says a license plate is 3 digits followed by 3 letters. So if I can repeat, that means how many choices do I have for the first number, like in my license plate? The first number in my license plate, I have 10 choices. The second number of my license plate, I still have 10 choices because I can choose any number I want. The third option on the license plate, the third number, I can choose between 10 as well again. Why? Because it doesn't matter if they repeat. So the point is I have 10 digits to choose from for the first one, 10 digits to choose from for the second one, 10 digits to choose from for the third one. Then it says I follow by 3 letters. Well, how many letters do I have to choose from? 26. And I could have it repeat. So I could have this be 111, AAA. I could have this be 222, LLL. It doesn't matter, which means I have 26 letters to choose from for this one, and I have 26 letters to choose from for this one, and I have 26 letters to choose from for this one. The reason I know when to stop is it says 3 numbers, 3 letters. So I just multiply all that together to get 17,576,000. Now, what would happen if I can't repeat any of the numbers or any of the digits? Well, what that means is my first choice, I have 10 choices still for all of my numbers. I can choose any of them I want. I have 10 different digits to choose from. So let's say I chose the number 1. I can't choose the number 1 here. So I don't have 10 choices anymore. I only have 9 choices. So let's say I chose the number 2. Now I can't choose the number 1, and I can't choose the number 2, so I really only have 8 choices of numbers left. So now I'm on to the letters. I have 26 different letters I can choose from, so let's say I choose the letter A. I can't choose the letter A again, so I now have 25 choices. Let's say I chose the letter B. I can't choose the letter A or B, so since I can't choose the letter A or B, I now have 24 choices. So when I multiply that together, I get 11,232,000 combinations. So when we come back, I want to talk about permutations and figure out when we use permutations and the importance of using permutations. When we come back.